Hi, I'm Mahalya. Today's topic is atomic structure. Atomic structure. Okay. This atomic structure which explains structure, bonding, arrangement of an atom. Okay, these three: atomic structure which explains structure, bonding and arrangement of an atom. So in this topic there are types of atomic models. Okay, there are 5 types. First one, Dalton's atomic model. Okay, first one is Dalton's atomic model. Second one is Thomson's atomic model. Second one is Thomson's atomic model. Third one is Rutherford's atomic model. Okay, Rutherford's atomic model. And fourth one is Bohr's atomic model. Bohr's atomic model. And fifth, Sommerfield's atomic model. Okay, these are the types which explains atomic models. Okay, first one is Dalton's atomic model. Dalton's atomic model. Here the scientist Dalton said that atom is smallest one. Atom is the smallest one and it is impossible to split into particles. Okay, Dalton said that atom is the smallest and it is impossible to split into particles. Okay, and it is also an earlier atomic model. Okay, this is the first atomic model. That's why he named as father of atom. Okay, father of the atom. And second, Thomson's atomic model. Thomson's atomic model. Okay, these Thomson scientists said that the atom having both positive and negative charges, he just he said that both negative and positive charges are present in atom. That's why he called it as plum pudding model. Actually, he assumed atom as a watermelon, and inside seeds and pulp, and he assumed seeds as a negative charge and pulp as a positive charge. So that's why he said that atom like a watermelon, and atom having both positive and negative charges. That's why he called it as a plum pudding model. Okay, plum pudding model. That's why he said it as a plum pudding model. Okay, for this, in 1906 he got Nobel Prize. After that, it's proved as wrong statement. Okay, it's proved as wrong. Okay. Third, Rutherford's atomic model. Okay, Rutherford atomic model. These scientists said that an atom is in spherical shape. Okay, an atom is in spherical shape, like this, spherical shape, and also he said that nucleus, which is present at the center of the atom and having a positive charge. So nucleus present at the center of the atom with positive charge and atom in the spherical shape. Okay, and he proved this nucleus having positive charge by gold foil experiment, that is alpha scattering experiment. Through this experiment, he proved that nucleus having the positive charge and it present at the center of an atom. Okay, that's why he named as the father of nuclear physics. Okay, that's why he named as father of nuclear physics. Okay, and also some information about him, which is the radium activity, which expressed as RD. That means Rutherford. Okay, Rutherford radium activity, which expressed in RD, and these RD having 3 units. First Becquerel, Rutherford, and Curie couples. Okay, which is RD is equal to 10 to the power of 6 Becquerel. okay, or 10 to the power of 6 disintegrations, okay, disintegrations per second, okay. Radium activity, which expressed as RD. RD means Rutherford, and RD is equal to 10 to the power of 6 becquerel or 10 to the power of 6 disintegrations per second. And this RD which expressed as 3 units, which is becquerel, Rutherford and Curie, okay. And fourth one is Bohr's atomic model. Bohr's atomic model. Niels Bohr explained that electrons revolving in stationary orbit, okay, in stationary orbit or stationary energy level or shell, okay. Niels Bohr explained that electrons, okay, electrons which are revolving in this stationary orbit or stationary energy level, these electrons are revolving here. He explained this concept. Only for hydrogen, okay, only for hydrogen. For this he got a Nobel Prize. In 1922, okay. Niels Bohr explained electrons which are revolving in stationary orbit or stationary energy level. Only he explained this concept only for hydrogen, okay, only for hydrogen. And for this he got a Nobel Prize in 1922, okay. Fifth one is Sommerfeld's atomic model, okay. He explained that in an atom, electrons moves in elliptical pathway, okay, elliptical path, okay. Sommerfeld explained that in an atom, electrons are moves in elliptical path, okay, elliptical path. And he said that long axis and short axis concept, okay. This is the short axis and this is the long axis. He explained this concept, and he said that electrons which are move in elliptical path, okay. Here I just simplified as, okay, a small table, okay. Make a table. Serial number, types of atomic model, types of atomic model, scientists, okay, and concepts, and if any of one called as father, okay, and Nobel Prize, okay, Nobel Prizes. Just make a small table. We can easily remember these with this table, okay. First one, earlier atomic model, which is Dalton's atomic model. Okay, Dalton's atomic model, and the scientist is Dalton, and the concept is he said that atom is smallest and impossible to split into particles. Okay, and he named as father of atoms. Okay, and okay, last and second, Thomson's atomic model. Okay, Thomson's atomic model. Scientist Thomson, and he said that atom like a plum pudding model, which like a watermelon and having both positive and negative charges. Okay, and he got a Nobel Prize in 1906, but later it proved as a wrong statement. Okay, and third, Rutherford's atomic model. And scientist Rutherford, and he said that atom having a nucleus. Okay, nucleus at center and having positive charge. He explained it with gold foil experiment, that is alpha scattering experiment. Okay, and that's why he named as father of nuclear physics. Okay, and he got Nobel Prize in 1908. Okay, and fourth one, Bohr's atomic model. Okay, scientist Niels Bohr, and he said that in an atom electrons revolves in stationary orbit or stationary energy level. Okay, stationary energy level only for hydrogen atom. Okay, and for this he got Nobel Prize in 1922. Fifth one is Sommerfield's atomic model. Scientist Sommerfeld, and his concept is elliptical and long axis, short axis. Okay, electrons moves in elliptical path. He said that electrons moves in elliptical path in an atom. Okay, which having long axis and short axis. Okay, this is the simple table. We can remember it in easy way. Okay, and we have to remember some basic concept about nucleus, which is in positive charge. Assume it's a nucleus, and inside the nucleus having both protons and neutrons. Okay, protons having positive charge and neutron are in neutral state. Okay, both protons and neutrons are in nucleus. Okay, and we have to remember some terms, okay, which is shell, subshell. Okay, these shell or stationary orbit or stationary energy level, okay, in an atom. Okay, we have to remember these terms. Here K shell. Shells are K, L, M, N, okay, or 1, 2, 3, 4 energy levels. Okay, K, L, M, N, okay, or first energy level, second energy level, third energy level, fourth energy level. Okay, or first orbital, second orbital, third orbital, or fourth orbital. Okay, and here subshell means s orbital, p orbital, d orbital, f orbital. Okay, s orbital, p having 3, okay, p orbital, and d having 5, 1, 2, 3, 4, 5. Okay, f having 7, 1, 2, 3, 4, 5, 6, and 7. Okay, these are the orbitals, okay, or subshells. Okay, and here we have to know about number of subshells in a stationary phase or stationary orbital. Okay, okay, stationary orbit, okay, by n square. Okay, okay, n square. If n is equal to 1, that is first energy level, that means we have to substitute that one in this formula, that is 1 square, that is 1, means s only, s orbital only. Okay, and if n equal to 2, that is 2 square, that means 4, that is s and p, that means s and p, which is here 1 s. Okay, here 4, s is 1 and 2, 3 and 4. Okay, and if n equal to 3, that means 3 square is equal to 9, that means s, p and d, that is s, p and d, 1, 2, 3, 4, 5. Okay, you can count 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, 9. And if n equal to 4, that means 4 square is equal to 16, that is s, p and d and f. Okay, that is s, p 1 2 3 4 5. D and F having 7. 1 2 3 4 5 6 7. Okay, F. You can count 1 2 3 4 5 6 7 8 9 10 11 13 14 15 and 16. Okay, okay, okay. You can count as, okay, 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 and 16. Okay, 1 3 and 5 and 7. You can count like this. Okay, so you can happily determine number of subshell in stationary file by using this n square formula. Okay, and next, number of electrons in each shell or stationary orbit or stationary energy level. Okay, this explained by 2n square. Okay, if n equal to 1, that is, we have to substitute this value in n place. Okay, 2 into and 1 square, that is 2. Okay, okay, that means in s orbital we have to fill 2 electrons. Okay, okay, assume like this is an s orbital and we have to fill 1 and 2. This is 1 electron and this is second electron. Okay, if n equal to 2, we have to substitute that value in n 2 square, that means 4 8. Okay, that is, we have to fill these electrons. This is the electron and we have to fill, these are the orbitals. Okay, s and p. Okay, always we have to fill like this. Later we again fill like this. Okay, okay, you can count 2 4 6 and 8. Okay, if n equal to 3, that is 2 means 18, that is SPD. Okay, S okay, and 1 2 3 4 and 5. Okay, and we have to fill electrons like 1 2 3 4 5. Okay, already here 8 electrons have filled, and here extra 5, 8 plus 5 13. Okay, remaining electrons we have to fill like this. Okay, okay, these are the s and p, s p and d. Okay, here n equal to 4. If 4 square means 2 and 16 means 32. Okay, that s p d and f, that is s okay 1 2 3 4. Okay, and later we have to fill like this: 1 2 3 4 5 6 and 7. Okay, f orbital we have to fill like this. Okay, later this. Okay, this is the f orbital, this d p p and s orbital. Okay, like this we can fill the electrons in these orbitals, okay, by using this 2n square formula. For filling of number of electrons in each shell is 2n square, and to find the number of subshells in stationary orbit is n square. Okay, in this here 2, 8, 18, 32, these are the electrons which are filled in each shell. Okay, like this. Okay, I just make a small table, through that you can remember these things easily. Okay, first serial number, subshells, okay, shells, subshells, okay, number of subshells, okay, number of electrons in shells. Okay, through this table you can easily remember this concept. Okay, we have to prepare every concept in a simple and shortcut method. Okay, we have to prepare like this. Okay, first K, L, M, N. Okay, 1, 2, 3 and 4. Okay, subshells. Here 10 shell having, or 10 stationary orbital having s, okay, s orbital, and number of subshells here 1 subshell. Okay, that is 1. Okay, and here sp. Okay, number of electrons in shells is here 2. Okay, I said earlier the concepts, which is number of subshells by n square and number of electrons in subshells by 2n square. By this formula we can easily determine this. Okay, 1 and 3, that is 4. Okay, here spd, okay, which is 9, that is 1, 3 and 5. Okay, and spdf, that is 16, which is 3, 5 and 7. Okay, and also number of electrons in shells, okay, which is 2, 8, 18 and 32. Okay, I'll explain again. Okay, nucleus, which having protons and neutrons which is in neutral form, and protons in positive charge, and which having stationary orbits or stationary energy levels, or shells which indicates with K, L, M and N. Okay, K, L, M, N. Okay, and here and also like 1, 2, 3, 4 energy levels. Okay, and here for these shells having number of electrons by 2n square, which is 2, K shell having 2, and L shell having 8 number of electrons, M having 18 and N having 32. Okay, and these electrons filled in S, SP, SPD, here SP, D and F. Okay, these subshells. Okay, this is the simple way. This is the simple way, and I hope you like this video. Okay, and this class which I explained in very neat, and remaining concept will continue in the next class. Okay, thanks.